morning. Am I audible? Is there any disturbance? Am I audible? Is there any disturbance? Okay, I'll start the class. Am I audible now? Am I audible? Am I audible now? Okay. Okay. Any disturbance? If there is disturbance, please inform. Okay, then I will start the class. So I will discuss the stability analysis, which is more important actually to know this concept. So I'll give you time to write down the notes. So let us start. So as I'm explaining, you can note it down in your notes. So draw the Nyquist plot for the system whose open loop transfer function is given, that is g of s h of s is equal to k into 1 plus s square by s cube. I will expand the screen. So in this numerical problem, we have to draw the Nyquist plot for the system, okay, for the system whose open loop transfer function is g of s h of s equal to k into 1 plus s whole square by s cube. And we have to determine the range for k for which closed loop system is stable. Okay, so we have to determine the range. Means k should lie, there should be lower value and a higher value of k. K should lie between two values. Okay, so in between lower limit and higher limit, within lower and higher limit, what within those limits, what is the range? That is the range means always a particular value. It's if the value lies between that lower and higher values, in between those two range values, then whatever may be the value of k between those two lower value and higher value, the system will be stable. So the range of k, not a k value is not fixed. They have asked the range of k for which the closed loop system is stable. So let us first of all consider this g of s, h of s. Please write down the question as quickly as possible. If you complete, inform. If you complete, inform in the chat box so that I will proceed. Write down the question quickly. If you complete, type completed. You people write it down parallel to what I am discussing so that our time will be saved. So now the given open loop transfer function is g of s h of s is equal to k into 1 plus whole square by s cube. This is our given open loop transfer function. So by looking at this open loop transfer function, if you look at the denominator term, if you look at the denominator, what is there? There is an s cube. Okay, so s power 3. So the denominator indicates that there are 3 poles at the origin. Okay, so there are 3 poles lying at the origin. So it is written here. Where is my cursor pen? Yeah. So there are 3 poles lying at the origin. Okay, so and let us draw the Nyquist contour, which will lie on the right half of your entire S plane. Okay, so since there are, even if there is a 1 pole or 2 pole or 3 poles lying at the origin, so we already know that means that there is a singular point on the imaginary axis. Therefore, in general, if there is no pole lying on the imaginary axis, or if there is no singular point on the S plane, then there will be only three sections in your Nyquist contour, since now there is a singular point. Okay, not even a singular, of course there are 3 poles, their location is same, that is at the origin. Therefore the counter will not enclose that part, that is the origin part. Therefore there will be 4 sections in the Nyquist contour. Okay, so our Nyquist contour will be somewhat like this. So actually Nyquist contour should have C1, C2 and C3 sections. But since there are 3 poles, even if 1 pole is lying, okay, on this, at whichever point it lies on the imaginary axis, that is our singular point. So the counter will never enclose the singular point. Therefore, it will bypass the singular point. So draw 3 poles, one above another. It seems there is only 1 pole at the origin. You can draw 3 poles, one above another at the origin. Okay, draw 3 poles, one above another at the origin. Here I have drawn only 1 pole. Means it looks as if there is only 1 pole, but there are 3 poles at the origin here. So just locate all the 3 poles at the origin. Okay, and draw the Nyquist contour, which lies on the right half of your S plane. Draw it quickly. So this is our Nyquist contour. So instead of having C1, C2 and C3 sections, C1, C2 and C3 sections, we have another section, that is C4 section. The C4 section came into existence because of the singular point that is lying on the imaginary axis. So here actually 3 singular points are there, but all of them are overlapping one above another. Therefore, only one extra section has come into existence, that is C4. So now we have 4 sections, C1, okay, C1, C2, C3 and C4. Total 4 sections are there. So for C1 section, its section varies from omega equal to 0 to plus infinity, whereas C2 section varies from plus pi by 2 to minus omega theta angular displacement. Okay, so theta for this, not angular displacement. So the theta, the limits for this arc, okay, it's not the angular displacement. The limits for this is an arc, isn't it? This is an arc. So the limits for this arc are theta equal to plus pi by 2 to minus pi by 2. Sorry. So theta equal to plus pi by 2 to minus pi by 2. Okay, theta equal to plus pi by 2 to minus pi by 2. These are the limits, theta limits for this arc C2. Whereas C4 section, it will vary from omega equal to minus infinity to omega equal to 0. Again, I'm sorry, this is C3 section. Again, C4 section. So this is C4 section is again an arc. So arc will have limits, that is theta equal to minus pi by 2 to plus pi by 2. Okay, so my cursor, okay, so for C3, it will vary from minus pi by 2 to plus pi by 2. So that we will discuss in the next slide. So let us start with section 1, that is C1. Okay, mapping of section C1. So mapping of section C1. So in section C1, omega will vary from 0 to plus infinity. That's what we have seen here. For C1 section, you can see omega varies from 0 to plus infinity. Okay, so this mapping of section C1, it will be given by the locus of g of j omega and h of j omega, as omega varies from 0 to infinity. So this locus is nothing but the polar plot. So first of all, let us consider the given open loop transfer function g of s h of s. What is it? K into 1 plus s whole square by s cube. So this is it. Okay, this is given in the question. Now replace s by j omega. Replace s by j omega. If you replace s by j omega, you will get g of j omega, h of j omega equal to k into 1 plus j omega whole square by j omega cube. Okay, so what is this? This numerator term, if you observe, this is in the form of, I'm sorry, this numerator term in this equation, it is in the form of a plus b whole square. It is in the form of a plus b whole square. So this is in the form of a plus b whole square form. So just expand it. A square plus b square plus 2ab. You will get, this is a square plus b square plus 2ab. Okay, a square plus b square plus 2ab form. Just expand it. You will get this. Okay, so after expansion, you will get this. Just write it down quickly as possible. Just write it down. Okay, so after expansion, just divide with the denominator, divide the numerator term with the denominator. Before division, you just make sure you write all the real terms on one side and imaginary terms on the other side. If you see, this is j square, means you will get minus 1. So this is our real part, this is our imaginary part. So this 1 plus j omega square, it will become 1 minus omega whole square. So there is no need to write 1 minus omega whole square. Okay, you can write 1 minus omega square. So to 1, even if you write square, it doesn't matter actually. That's why I have written that. So you just split it. Okay, you just split this. You will get this. Okay. So here I have missed one bracket. This is it. This is square bracket. 1 minus omega square whole divided by j omega cube. So I will just I'll just modify this equation. So let me check. So it is, I'm unable to modify it, but this is it. Don't put this bracket. This bracket is not there. Okay. Don't put this bracket. So this is not there. Okay. So just write down k into this is not there. Don't write it. Draw it. So k into 1 minus omega square. This square should be here. Okay. It has gone to the numerator. It's okay. So I simply copied from the numerator and wrote it in the above equation. I copied it and pasted it in the lower section. Okay. So I just copied it and pasted, and I forgot to remove this bracket. That's it. Nothing else. Okay. So now what is it? K into 1 minus omega square by j omega cube plus k into 2j omega by j omega cube. This is it. Write it down quickly. If you are completed, inform. This is not there. Okay. Okay, now let us proceed. See, here I have written it in a proper way. Okay, now. So I have just send the denominator j value to the numerator. Here we have a j in the denominator. I have sent it to the numerator. See, this j and this j will be cancelled. And this minus j, you send it to the numerator. So you will get this expression. Simply mathematical simplification. So there was a bracket, extra bracket, which I forgot to remove it. So that's why in the previous slide it was a bit confusion, but it's okay. So there was nothing to explain. Simply mathematical simplification, just expand it and write it down. That's it. So in the denominator, whatever j term was there in the previous slide, you just send it to the numerator. Here j cancel. This minus j go to the numerator term. So you will get this expression. So this is our expression now. G of j omega, h of j omega. You will get minus 2k by omega square plus j into k into 1 minus omega square by omega cube. Okay. This is it. Now, we know polar plot, isn't it? We know polar plot. Let us assume this is some just so okay. So some plane. Okay. And here suppose this is my polar plot. Okay, just for example. Okay, just for example, in order to explain, I am drawing this. So let us assume this is my real axis sigma and this is my j omega axis. Okay, so this is sigma, sorry. So this is sigma, this is j omega. Okay, so now suppose this is my plot. Okay, so I will change the color so that it will be more clear. So suppose this is my plot. Blue color line is my plot. So this blue color line or this blue color curve, it intersect the real axis, isn't it? This is sigma. Sigma means what? Real axis. So it intersects the real axis at some point, means it is crossing the real axis at some point. So whenever this is our polar plot, isn't it? The polar plot we usually draw on the real and imaginary axis quadrants. So then we are converting the polar terms into rectangular to plot the graph of polar plot. So if this, let us assume this is our polar plot, and if this is our polar plot on our rectangular coordinates, so sigma and j omega are rectangular coordinates. So this polar plot is crossing the real axis at some point. So when our polar plot crosses the real axis at some point, what will happen? When our polar plot crosses the real axis at some point, what will happen? Imaginary terms at that particular crossing point will be equal to 0. Only real terms will be there and imaginary terms will be equal to 0. Okay. So only real terms will be there. That's what I have written here. Whenever g of j omega, h of j omega locus crosses real axis, imaginary term will become 0. Okay, at the crossing point on the real axis, at this particular point on the real axis, okay, what will happen? What will happen? At this particular point on the real axis, imaginary terms will become 0. So let us assume this plot crosses the real axis. Okay, this plot crosses the real axis. Let us assume it crosses the real axis. So when it crosses the real axis, imaginary term should become 0. What is our imaginary term in g of j omega, h of j omega? This is our imaginary term, k into 1 minus omega square by omega cube. Okay, k into 1 minus square by omega cube is our imaginary term. So the frequency at that when polar plot crosses the real axis, that frequency is known as phase crossover frequency, that is omega pc. The frequency at which polar plot crosses the real axis, that frequency is known as phase crossover frequency. If you people want me to repeat from the beginning, you just type repeat, so that once again I will start the numerical problem if you are unable to follow. If anyone is unable to follow, just type repeat. I will once again start the numerical problem. Okay, so because you have to understand, otherwise you won't be able to write the exam properly. So see, if you plot the polar plot, okay, and whenever polar plot is crossing the real axis, okay, when it crosses the real axis at that particular instant, the imaginary term will be 0. Okay, so only real terms will be there when the polar plot is crossing the real axis. So that's why g of j omega, h of j omega locus, when it crosses the real axis, imaginary term should become 0. And the frequency at which it crosses the real axis, that frequency is known as phase crossover frequency. Okay, so that phase crossover frequency, so omega equal to what? Omega becomes omega pc when imaginary term equal to 0. What is our imaginary term? K into 1 minus omega square by k into 1 minus omega square by omega cube, that is equal to 0. So just simplify it. Okay, if you simplify it, you will get some value for omega pc, phase crossover frequency. So k k into 1 minus omega square by omega cube equal to 0. Send denominator to the right side. K into 1 minus omega pc square equal to 0. So k also will become 0 and 1 minus omega pc square equal to 0. So omega pc is equal to 1 radian per second. Okay, omega pc will be equal to 1 radian per second. So when omega equal to omega pc, what is it? G of j omega h of j omega is purely real value. It will be equal to purely real value. Imaginary term is 0. So when omega equal to omega pc, g of j omega h of j omega is equal to what? Minus 2k by omega pc square. Here omega is there in the denominator. So instead of writing omega, I will erase all inks. Okay. So when omega equal to omega pc, g of j omega h of j omega is purely real value. Okay, it is equal to purely real value. Since it is equal to purely real value, okay, since it is equal to purely real value, therefore, g of j omega h of j omega is equal to minus 2k by omega pc square. So substitute omega pc value, you will get some value for g of j omega h of j omega. So I will once again repeat the numerical problem. I just want to write it separately. I'll once again repeat from the beginning so that if those who have joined lately, they will be able to understand. Okay, so I'm going to start once again. I'll make it fast as quickly as possible. I will repeat. So in this numerical problem, draw the Nyquist plot for the system whose open loop transfer function is g of s h of s equal to k into 1 plus s whole square by s cube. So this is our g of s h of s equation, open loop transfer function that is given. So determine the range of k. So we have to determine the range of k. So there must be, so there must be some value for the k must have certain range. Okay, k must have certain range. So if the k value lies between that range, then the closed loop system is a stable system. Okay, closed loop system is a stable system for that particular range of k values. Okay, for that particular range of k values, closed loop system will be a stable system. So we have to determine that range of k values here. Okay, so let us consider g of s h of s, that is k into 1 plus s whole square by s cube. Now if you look carefully into the denominator of g of s h of s, okay, so denominator consists of only s to the power of 3. That means there are three poles lying at the origin on the s plane. Okay, there are three poles lying at the origin of the s plane. Therefore, we already know Nyquist. What is Nyquist counter? Nyquist counter, it is the It is a semicircle. Sorry, this my cursor. If I press it hardly, then this is what is happening. This is what is happening. So we know Nyquist plot. It is a semicircle lying on the right half of S plane. So this is the semicircle which is lying on the right half of S plane. And Nyquist counter, it will be consisting of three sections. It will be consisting of three sections. Those sections are, oh no. So those sections are, sorry. So instead of drawing, it's better if I show you. So it's better if I show you the Nyquist counter instead of drawing it again and again. If do I have any Nyquist counter? Let me check. Okay. Yeah, I have Nyquist counter. So Nyquist counter will be having only three sections. So this is the Nyquist counter. It will have only three sections: C1 section, C2 section, and C3 section. Okay. So where C1 varies from omega equal to 0 to omega equal to plus infinity, C2 varies from plus pi by 2 to minus pi by 2. C2 is an arc. Where C3 varies from omega equal to minus infinity to omega equal to 0. But so quickly I will go back. But here if you see, there are three poles lying at the origin. Okay. So as according to the theory that we have already discussed, if there are singular points, Nyquist counter will never enclose the singular points. If there are singular points, Nyquist counter will never enclose the singular points. Therefore, instead of three sections, you will get four sections. Why? Because wherever the singular point lies, the singular point lies at the origin, isn't it? The singular point lies at the origin. Three singular points overlapping one above another. So those singular points are the three ports lying at the origin. An arc will exist. So our Nyquist counter will be modified to this form. So you can now this new Nyquist counter will have C1 section. For C1 section, omega varies from omega equal to 0 to omega equal to plus infinity. Another section is C2 section. For this arc C2 is the arc. For this arc C2, theta will vary from plus pi by 2 to minus pi by 2. And another section is C3, for which omega will vary from omega equal to minus infinity to omega equal to 0. Another arc will come into existence to bypass this singular points which are lying on the imaginary axis. So the C3 section has come into existence because Nyquist counter will not enclose the singular points. Okay, Nyquist counter will not enclose the singular points. So C4 section came into existence. So now radius of C2 section is r equal to infinity. So r tends to infinity. I should not say equal. And radius of C4 section is r tends to 0. Okay, for C2 section, the radius is infinity. For C4 section, radius is 0. Okay, so because the poles are lying at the origin. Now we have total 4 sections here. Okay, we have 4 sections. Let us determine the Nyquist counter for each section. Okay, Nyquist counter for each section. So let us start with mapping of section C1. So now, as I said, omega varies for C1 section. Omega varies from 0 to plus infinity. Okay. Now, let us consider g of s, h of s. That is k into 1 plus s whole square by s cube. Replace s by j omega. If you replace s by j omega, you will get g of j omega into h of j omega equal to k into 1 plus j omega whole square by j omega whole cube. Now expand 1 plus j omega. If you expand, sorry, There was a disturbance. So just expand 1 plus j omega whole square. Then if you expand it, then it is in the form of a plus b whole square. You just expand it, you will get a square plus b square plus 2ab. This is our a square, this is b square, this is 2ab. So you just expand it. After expansion, you just divide it with the denominator. If you divide it, you will get, you just separate the real terms. This is j square, it will become minus 1. So this is our real term. This is our imaginary term now. So write real term separately and imaginary term separately. Okay. So after writing real term separately and imaginary term separately, you can see this j and this j will cancel, and this minus j, you can send it to the numerator. It will become plus j. Okay, simple mathematical simplification, nothing technical from here to here. So if I press my cursor for a bit longer time, it is creating its own image. So I should not press it properly. So see, whatever up to from here to here, this is simple mathematical simplification. Nothing much complicated is there. So you can do it. You can do it. So I hope you have understood. Let us go to the next slide. So now what, based on simplification, this is my real part. Okay, this is my real part. This is my image. So this is my real part. This is my imaginary part. Okay, we have a real part and an imaginary part. Now if you plot a polar plot, okay, so if there is a if you plot a polar plot on the rectangular coordinates, so these are my rectangular, sorry, my cursor is not listening to me, it is not obeying my instructions, so it is drawing its own shape, so I'm unable to use it properly. Okay, so sigma is real value and real axis, and j omega is imaginary axis. If there is a polar plot, let us assume this is my polar curve. So this polar plot intersects the real axis at this particular point, isn't it? So when polar plot crosses the real axis, when polar plot crosses the real axis, what about the imaginary terms? Imaginary terms are 0. Similarly, when g of j omega g of j omega and h of j omega locus crosses real axis, imaginary terms will be 0. So whenever g of j omega, h of j omega locus crosses a real axis, the frequency at which it crosses the real axis, that frequency is known as phase crossover frequency. Okay, that frequency is known as phase crossover frequency, which is denoted by omega pc. I hope you have understood. I am trying my level best to teach in the as simpler possible way as possible. Okay, as simple as I am keeping my language as simple as possible. Okay, so we know simply based on this diagram which I have drawn here. So based on this, you can understand the concept. So whenever polar plot crosses the real axis, imaginary terms are 0. Similarly, similar to that, whenever g of j omega and h of j omega locus crosses real axis, imaginary term will become 0. The frequency at which imaginary terms will become 0, that frequency is known as phase crossover frequency. So at phase crossover frequency, what is it? Imaginary term. What is our imaginary term in g of j omega, h of j omega? This is our imaginary term. Okay, I will erase all links. Okay, so at omega equal to omega pc, okay, this imaginary term, this is our imaginary term in g of j omega, h of j omega. So that imaginary term, okay, that imaginary term should become equal to 0. So I have written here imaginary term, that is k into 1 minus omega square by omega cube is equal to 0. Just simplify it. Okay, just simplify it, you will get some value for omega pc. you will get some value for omega pc. So here I have got omega pc equal to 1 radian per second. Okay, here I have got omega pc is equal to 1 radian per second. So when omega equal to omega pc, what about g of j omega, h of j omega? It is purely real value. It is equal to this term. So when this is 0, okay, when this has become 0, then what is left over? G of j omega, h of j omega is equal to minus 2k by minus 2k by omega square. Okay. So when this is not there, this has become 0. So my cursor is not listening to me. So when this term has become 0, so what is left over? G of j omega, h of j omega is equal to minus 2k by omega square. So are you able to follow or not? Mention in the chat box. I am able to reach you people or not. Okay, I am keeping it as simple as possible. I don't know how many of you are able to follow, but I am trying my best to keep it as simple as possible. So I will just check whether if there is any disturbance or if there is any issue. If my screen freezes, if my audio is not matching with the screen, you people just inform me. Okay, so this topic is important. If those who are unable to attend this class, I can't help you. Okay, so if you are unable, if others are busy and they are unable to attend, then it's their own wish. Okay, their subject, their wish. They have to write their exam. That's it. So omega pc. So at omega pc is equal to 1 radian. What about g of j omega h? Substitute omega pc value in the above equation. You will get g of j omega h of j omega is equal to minus 2k. Okay. Now you can locate that in your g of j omega h of j omega plane. Okay. You can locate that point on g of j omega and h of j omega plane. So you know the g of j omega and h of j omega plane real axis is u and imaginary axis is j v. Okay, so locate that point in your notes. Sorry, my cursor is not listening to me. So the suddenly a line. If I press it hardly, a line is coming into existence. So consider this point. It is my minus 2k. This is my minus 2k. So just draw. Okay, just draw it. Just draw the g of s h of s plane. Actually, this is g. Just locate this point on on g of s h of s plane. This is g. This is what happens if I press my cursor hardly. A line is. So if there is an option for typing text, then I might have used that option. I'm unable to write here properly, but this is it. G of s h of s plane. This is plane, plane plane. You write it down. Okay, G of s h of s plane. So this is it. Locate this minus 2k. Consider it as equation 1. Okay. Now let us proceed. So now g of j omega h of j omega equation is what? K into, consider the actual equation, k into 1 plus j omega whole square by j omega cube. Write down the real terms and magnitude terms and angular terms. Okay, magnitude and phase for each and every term. Okay, write down the magnitude and phase for each and every term. So what is the magnitude for 1 plus j omega whole square? Okay, it is you just you can expand it and later you can write it down. Okay, so it is k into under root of 1 omega square at an angle of tan inverse omega, root of 1 plus omega square tan inverse of omega by j omega cube. Magnitude is omega cube and angle is 270. Did I write twice? No. Okay, write down the magnitudes and phase angles. So take the write magnitudes aside. Okay, write magnitudes aside, root 1 plus omega square and 1 plus omega square you will get roots will be cancelled, you will get 1 plus omega square. Okay, here k is there, so omega by omega cube, this should become omega square. So omega by omega cube means in the denominator you should get omega square. Instead of omega cube you should get omega square. Some of your friends were telling me they didn't know about the class. So inform your friends to join the class. This topic is important. This topic is important. That's why. Okay then. So here, where was I? Yeah. Here I will just here in the numerator. This is 2, not no cube. No. In this here, it is 2, not 3. Why? Because here omega is there. So omega will cancel and you will get omega square. Okay, so I will just expand it. So this is it. You have magnitudes and you have phase angles for different omega values similar to your polar plot. You can determine the magnitude and phase angle separately, or since we are not going to use any scale directly, you are going to plot the graph on the notes. Instead of plotting it on the graph, simply you can consider only two limits. You can consider two limits, omega equal to 0 and omega equal to infinity. Substitute omega equal to 0 in the above equation, omega equal to infinity in the above equation. You will get when omega equal to 0, you will get magnitude infinity and angle minus 270 degree. And when omega tends to infinity, magnitude will become 0 in the above equation. In this equation, substitute it and angle you will get minus 90. Okay. So this is what you will get. So simply you have to take g of j omega, h of j omega equation and you just write down the magnitude and phase angle for each and every term that is available in the equation. Separate the magnitude terms, separate the phase terms, and for omega equal to 0, omega tends to 0 and omega tends to infinity, substitute it in the above equation. Okay, substitute it in the above equation and determine the magnitude and phase angle. So what is our magnitude? Magnitude is infinity and phase angle is 270. For omega tends to 0 and for omega tends to infinity, magnitude is 0 and phase angle is 90 degree, minus 90 degree. So minus 270 and minus 90, and we already know, I can't draw it. So we already know. So I will try my best to draw. So if these are the four quadrants, these are 0 degree and this is minus 90 and this is minus 270. Okay, this is minus 90 and minus 270. So magnitude is infinity. So from air, infinity. So from air it should start and it should end at, sorry. Again, I have pressed my cursor hardly. So erase. This is it. So the plot will start like this and it will end here. So I'm unable to draw with my cursor. So I will show you the diagram, which is there in the next slide. This is the plot. Okay. This is the plot. So this is minus 270. This is 270. Okay. And this is minus 90. So my cursor is not at all obeying me. Okay. So this is it. This is minus 270. This is minus 90. I will see. I have another cursor. Let me see whether I can use it. So minus, no, it is also same. So it is of no use. So this is it. Minus 270 axis. So from minus 270 plot will start. It will pass through this minus 2k and it will end at minus 90. This is minus 90. So you people already know. So I need not again and again tell you. So I wanted to draw or write something, but my cursor, it is not obeying my instructions. So this is minus 90. This is minus 270. At last I have succeeded to write something. So this is minus 270. So from minus 270, we know polar plot starts at omega. So here our counter, of course. So our section C1 starts at omega equal to 0 and it ends at omega equal to plus infinity. So omega equal to 0, it will start and it will at omega equal to plus infinity. So magnitude is infinity at the starting. So within in the air, the plot will start at minus 270 axis and it will pass through this minus 2k and it will end at minus 90. So if anyone is unable to follow, please inform. So C1 mapping of section C1 in G of S H of S plane. If anyone is unable to follow, please inform. Are you able to follow or not? Please inform. How to map C1 section in counter, please. Just mention in the chat box, because in the middle of the class I was disconnected because the battery of my laptop was dead. I didn't see that. Are you able to follow? Okay, then I'll proceed. So this is it. This is simple. Let us go to mapping of section C2. Let us go to main part is the stability analysis. Okay, main part of this concept is stability analysis. So you have to wait till the end. You have to wait till the end. This whatever I am discussing till now, it is you people already know actually. So for previous problems in the similar pattern we have discussed in the previous problem. Now let's go to mapping of section C2. So mapping of section C2 from S plane to G of S H of S plane, it can be obtained by setting what? S is equal to limit R tends to infinity. We know the radius of the section C2 is R tends to infinity. So S is equal to limit R tends to infinity R e power j theta, where theta varies from what? From plus pi by 2 to minus pi by 2, where S is R, S tends to R e power j theta and R tends to infinity. Radius tends to infinity. So since radius is tending to infinity, what will happen to S? S will tend to infinity e power j theta. So S is a very high value now. Since S is very high value, in the given equation 1 plus st, if 1 plus st term is there, then 1 will be very small when compared to st, because S is tending to infinity e power j theta. Therefore, S plus t value is very high when compared to 1. When S plus t value is very high when compared to 1, you can neglect 1. Therefore, 1 plus st term, if it is there in your given equation, so it may be a first order denominator factor or first order numerator factor, whatever factor is there. So if they are there, then you can replace 1 plus st form into st. Okay, you can replace 1 plus st by st. So you can see these are given open loop transfer function, that is k into 1 plus s whole square by s cube. So 1 plus s is there. So 1 plus s can be replaced by s. So you just neglect 1, write only s. So k s square by s cube. So k by s you will get. So what is g of s, h of s? It is k by s. So what about s? What about s? S is equal to what? S is equal to this. S is equal to limit R tends to infinity R e power j theta. So therefore, g of s, h of s at s is equal to, okay, g of s, h of s at s is equal to limit R tends to infinity R e power j theta. G of s, h of s is equal to what? K by s. So substitute s value in this k by s. So if you substitute s value, you will get k by limit R tends to infinity R e power j theta. Okay, substitute R tends to infinity in this equation. So if you substitute R tends to infinity, okay, so k by infinity is 0. E power j theta, send it to the numerator, you will get e power minus j theta. Okay. So once again I will repeat for mapping of section C2. Where is my cursor? It is here. So mapping of section C2. So mapping of section C2 from S plane to G of S, H of S plane. We want to map section C2 from S plane to which plane? To G of S, H of S plane. So while mapping, okay, S will be equal to limit R tends to infinity R e power j theta, where theta varies from plus pi by 2 to minus pi by 2, and s tends to r e power j theta, whereas r tends to infinity. When r is tending to infinity, s will tend to infinity e power j theta, means s value is very, very high. Therefore, 1 plus st, if it is there, if this sort of term is there in your given g of s, h of s transfer function, since s is very large value, you can neglect 1. Where is my cursor? It is here. So neglect 1. When is 1 will be very, very small when compared to st. So neglect 1. So 1 plus st will become st. So now consider the given equation g of s, h of s, that is k into 1 plus s whole square by s cube. So 1 plus s will become what? S. Why? Because s is very large. So s square by s cube, cancel s square, you will get k by s. So g of s, h of s is equal to g of s, h of s is equal to k by s at s is equal to what? At s is equal to limit r tends to infinity r e power j theta. Now substitute this s value in this s of k by s. If you substitute it, you will get k by limit r tends to infinity r e power j theta. So where if you substitute r value, so you will get r as infinity. Instead of r, write infinity. K by infinity is 0. E power j theta, is send it to the numerator. It will become e power minus j theta. Write it down quickly. If you complete, please inform. Write it down quickly. If you complete, please inform. So I hope I am clearly able to explain till now. So now we have got an expression here. What did we get? G of s, h of s is equal to what now? 0 e power minus j theta. Now what is this theta? What is this theta? Theta is varying from where? From plus pi by 2 to minus pi by 2. Now substitute theta values in this equation. Okay, substitute theta values in this equation. Let us go to the next slide. So in the next slide, theta is equal to what? Plus pi by 2, plus pi by 2. So if theta is plus pi by 2, g of s, h of s will become 0 e power minus j pi by theta. Pi by 2. If theta equal to minus pi by 2, g of s, h of s will become 0 e power plus j pi by 2. Okay. So just substitute pi by 2 in this powers of e. You will get this. Now, what is g of s, h of s now? For theta equal to plus pi by 2, it is 0 e power minus j pi by 2. For theta equal to minus pi by 2, g of s, h of s is equal to 0 e power plus j pi by 2. Now, what is the radius? Radius is 0. So, what is the theta values? Now, theta varies from minus pi by 2 to plus pi by 2. Okay. Radius, r value is what now? Is 0. What about theta? It varies from minus pi by 2 to plus pi by 2. See, this is minus pi by 2. This is plus pi by 2. Theta varies from minus pi by 2 to plus pi by 2. Okay. So, let us map this C2 counter, C2 section of Nyquist counter on G of S, H of S plane. Okay. Now, what was C2 section? C2 was an arc which was varying, whose limits theta values were from plus pi by 2 to minus pi by 2. Theta values were from, So theta varies from plus pi by 2 to minus pi by 2. My cursor is not at all listening to me. Okay, plus pi by 2 to minus pi by 2. So when theta was varying from plus pi by 2 to minus pi by 2, this was your counter, which was, you can see the direction is in clockwise. So now our theta varies from where? Our theta varies from minus pi by 2 to plus pi by 2, isn't it? So minus pi by 2 to plus pi by 2. Okay, and what about the radius? Radius is 0. So it was when it was varying from plus pi by 2 to minus pi by 2, the counter was clockwise. So now our theta is varying from minus pi by 2 to plus pi by 2. So counter should be opposite to this, that is in anti-clockwise. Okay, so counter on G of S S of plus plane will be in anti-clockwise direction. Okay, it is varying from minus pi by 2 to, this is minus, sorry. Okay, so this is from minus pi by 2 to plus pi by 2. What about the radius here? Here radius was infinity in S plane. So now what is the radius? Radius is 0. That's what we have got, isn't it? See, radius is 0. So mention that radius r tends to 0 and the limits of the theta are minus pi by 2 to plus pi by 2. So see, you can see on S plane the counter was in clockwise when theta was varying from plus pi by 2 to minus pi by 2. Now our limits are just opposite. So the counter will be in anti-clockwise direction from minus pi by 2 to plus pi by 2. So remember, so whenever you get limits from negative to positive, anti-clockwise direction arc you will get. If you get theta values from positive to negative, you must draw the arc in clockwise direction. So this is our counter for section 2. Okay. So mapping of C2 on G of S, H of S plane. I hope you have understood. You just mention in the chat box if you people are able to follow. If you are unable to follow, even if you are unable to follow, if you repeat me any concept, mapping of C1, C2, anything, you just mention. You just mention in the chat box so that I will repeat. Okay, now let us go to mapping of section C3. So the easiest part in Nyquist counter is always the mapping of section C3. Why? Because it is the mirror image of section C1. So section C1, omega varies from omega equal to 0 to plus infinity, whereas section C3, omega varies from minus infinity to 0. Okay, just opposite of C1. Okay, so it is just the opposite or mirror image of C1. So C3 is always the mirror image of C1. So you can see the reverse polar plot is given by the mirror image of polar plot with respect to the real axis. Okay, so since it is just the mirror image of C1, okay, so with respect to the real axis, you must draw the mirror image just opposite to what you have got on whatever mapping section that you have got for C1. Okay, just opposite to that you have to draw with respect to the real axis. So let us see how you have to draw. This is it. So if you remember C1, I will once show you the C1 section. This is the C1 section. Yeah, this is it. So this is C1. So you can see this is our counter, just mirror image with respect to the real axis. This is our C3. This is C3. Mapping of section C3. This is it, just opposite to it. Okay, so as omega, so omega is varying from minus infinity to omega equal to 0, just opposite to the previous case. Just opposite to the previous case, nothing else. So the easiest mapping section is always C3. Remember that. Okay, so just draw section C3 and the mapping of section C3. Draw both the sections. Now let us go to mapping of section C4. So C4 section you can compare it with your section C2. Only the difference is there the radius is infinity, here radius is 0. The only difference that you will get is that, and the limits there the theta value varies from plus pi by 2 to minus pi by 2 for C2 section. For C4 it varies from minus pi by 2 to plus pi by 2. It's just the opposite. So let us map this C4 of S plane on this G of S H of S plane. For that, what about S? S will be equal to limit R tends to 0 R e power j theta. Same formula, instead of infinity you must write 0 for R. And theta, what is theta? It is minus pi by 2 to plus pi by 2. So same formula for S tends to R e power j theta, R tends to 0, not infinity. Okay, so here R tends to 0. So as R tends to 0, what about S? S tends to 0 e power j theta. So S tends to 0, R value is 0. So S tends to 0 e power j theta means S value is very, very low. So since S value is very, very low, okay, since S value is very, very low, if there is any basic factor, first order numerator or denominator factor in your given G of S, H of S loop function, so if that any basic factor is there, then simply that in that basic factor, where is my, yeah, in that basic factor, S is very, very small, therefore ST will be very, very small when compared to 1. So 1 plus ST, you can replace 1 plus ST by 1 because S is very, very small. Okay, because S is very, very small. So sorry, where is it? Yeah, C4 section. So we know what is our G of S H of S k into 1 plus 1 plus S whole square by S cube. So instead of 1 plus S, write 1. 1 square you will get 1, k into 1 by S cube. So k by S cube you will get. So what is G of S H of S? K by S cube. What about S? S is limit R tends to 0, R e power j theta. Write it down. Okay then. So G of S H of S is at S is equal to limit R tends to 0, R e power j theta, G of S H of S is equal to what? K by S cube. Substitute S value in this above equation. You will get K by limit R tends to 0, R e power j theta whole cube. Okay. So substitute R value, that is 0. So K by, yeah, K by 0 is infinity. So this is it. K by 0 is infinity. So radius is infinity now. Denominator, in the denominator e power j theta cube was there. Send it to the numerator. It will become e power minus j 3 theta. Okay. Now radius is infinity. What about theta value? Theta varies for this C4 section. Theta varies from where? From minus pi by 2 to plus pi by 2. So substitute theta equal to minus pi by 2 in G of S H of S. That is G of S H of S is equal to infinity e power j into 3. Theta is pi by minus pi by 2. Minus minus plus, so pi by 2. 3 pi by 2. So when theta equal to pi by 2, substitute in G of S H of S, that is radius is infinity e power minus j 3 pi by 2 you will get. So radius is infinity and theta varies from plus 3 pi by 2 to minus 3 pi by 2. Theta varies from plus 3 pi by 2 to minus 3 pi by 2. So if my screen freezes, please inform. Okay then. So now, what is it? Infinity is our radius and theta values are, this is our radius. Theta is 3 pi by 2 to minus 3 pi by 2. Okay. So let us go to our plot. This is our counter, C4 counter with radius R tends to 0. Now we have got radius R tends to infinity. So we know this axis is what? This is our minus 270 degrees. This is our plus 3 pi by 2 means what? 270, isn't it? 3 pi by 2 means 270. So I will write 2. Again, it's not at all listening to me. I'm unable to write with my cursor. I think it's very, very sensitive. It's a sensitive cursor. Just slightly, even if I press slightly, 270. Okay, so see, it is going. Succeeded. At last I have succeeded. At last I have succeeded to write this 270. 270 means 3 plus 3 pi by 2 and minus 270 means minus 3 pi by 2. So definitely our plot should start from this axis and okay, and since it is positive, okay, it is starting from positive theta equal to positive value, it should, the plot should run in clockwise direction. So when angle theta varies from positive to negative, as I have already told you, the counter should move in clockwise direction. If theta is varying from negative to positive, counter should move in anti-clockwise direction. That point you just keep in your mind. I am once again repeating. If the theta varies from positive to negative, then counter should move in clockwise direction. If theta varies from negative to positive, then counter should move in anti-clockwise direction. Okay, so if you even if you observe in this S-plane counter C4, it varies from minus pi by 2 to plus pi by 2. You can see counter is in anti-clockwise direction. Okay, so here our limits are plus 3 pi by 2. That is plus 270 to minus 270. So plus 270 to minus 270. So from here to here, uh, 90-degree limit, isn't it? Plus 90 to minus 90, I can say. Again, minus 90 to plus 90, it is two. For one complete circle means half circle, half arc, or half circle means it is 90-degree. One more half circle means 180, and one more half circle means 270. Okay, so that is it. So for 270, you must get at least 3 half circles. So you must start with plus 270. So you must move, since it is positive, you must move in clockwise direction. So half circle for 90, again 90, half circle, again 90. Okay, I am unable to draw properly. I will try one more time. If I am unable to draw it, I will leave it. I don't have patience to draw again and again. Okay, so my cursor is not listening to me, but I will try my best. So from 270. So this is a 270 plus 270 axis, that is plus 3 by 2 axis. So from here you must draw the arc. This is up to this is our 90-degree limit. Okay, one more 90-degree from here to here, that is 180. 90 plus 90, 180. One more 90-degree. Okay, see, this is what happens. I'm unable. Okay, so one more 90. Oh, let's see. It has some spike-like things are coming into existence. I'm not drawing them. They themselves are coming. See, one more spike. I can't draw. I think so. I'll try one more time. I have already drawn two. This is the last one. This is the last one. I'm trying to draw it. That's it. Succeeded. So from plus 270. So one half for 90, one more half for 180, one more half for 270. Total three half circles. Okay, from 2 plus 270 to minus 270. So this is our C4 section counter. Okay, this is our C4 section counter. So all counters are over. Now we can combine all the counters together. I'll give you a minute so that you can draw it if you people are drawing it. Are you able to follow or not? Please mention. You have understood. Are you able to understand the concept or not? Please mention. The main part comes now, the stability analysis. Okay, I will discuss in detail stability analysis in a simple way so that you can understand the concept. So what I have done is I have I have drawn all the counters in the same slide. I have kept all the counters in the same slide to understand the concept. Now this is our C1, C2. This is our C1. Okay, this is C2. This is what happens. So I think I have to buy a notepad, some pad and a pen to write. This cursor is not listening to me. C3 and C4. All four section counters are there. Now C1. Let us start with C1. This is our C1, isn't it? What is C2? This is our C2. So this is C2. This is C2 and this is C3. Just opposite to C1 is C3. And what about C4? This is our C4. Okay. So you just look carefully. You will be able to understand. Okay. So I will take, instead of drawing, I have a laser pointer here. See, this is our C1. Okay. This is our C1. This is our C2. This is our C3. This is our C4. Okay. I hope you are able to understand. I'm trying my best. Okay, I'm trying my best to explain this concept. So C1 section from here to here, C2 section, C3 section, arrow marks are important. Next, C4 section. So this is my complete counter. This is my complete Nyquist counter. Okay, so this is our complete Nyquist counter for on G of S, H of S plane. Okay, now let us assume for the stability, and this is the main part, major part. So this I will explain in detail so that you will be able to understand this concept easily. We have come to the main part of this Nyquist criteria. Now let us assume that minus 2k is equal to minus 1. Why minus 2k is equal to minus 1? We already know that. So I will draw it here. We already know that if there is a counter, I can't draw. So we already know that this is what happens. So if there is a counter which is enclosing the origin, okay, and there is a point at the origin, which is minus 1 on the not sorry, if there is a point on the real axis which is minus 1 plus j0, okay, and if this counter encloses that point, if this counter encloses that point in anti-clockwise direction, okay, if this counter encloses the minus 1 in anti-clockwise direction, then the system will be a stable system. Okay, the system will be a stable system if this counter on g of s h of s plane, okay, on g of s h of s plane, if this counter encloses the minus 1 in anti-clockwise direction, then the system will be stable system. So we don't know whether the minus 1 is enclosed or not. We don't know that. Okay, so we have the complete Nyquist plot. So this is our complete Nyquist plot. We don't know whether minus 1 has been enclosed or not. So to try to analyze, to know the stability of the system, so let us consider that whatever point that we have got on the real axis, that is minus 2k, it is equal to minus 1. So whichever point that we got on the real axis, that is minus 2k, consider it is equal to minus 1. So if minus 2k is equal to minus 1, what about k value? K will be equal to 0.5. K will be equal to, if you are unable to follow, mention it. I will repeat. If you want me to repeat anything, you just type repeat in the chat box. I will repeat the stability analysis. So here we don't know whether the counter is enclosing the minus 1 or not in anticlockwise direction. So in order to understand, in order to analyze the stability of the given system, let us assume that minus 2k is equal to minus 1. So if minus 2k is equal to minus 1, then this k will be equal to 0.5. Okay, k value is what? 0.5. So k value is 0.5 when you are assuming, where is your plot? So this is our plot. So okay, we are when is k value equal to 0.5? When you are assuming this as what? This as minus 1 plus j 0. So when you assume this point as minus 1 plus j 0, okay, then k value is equal to 0.5. Okay, listen carefully. So k value is equal to 0.5. Okay, when you are assuming minus 2k is equal to minus 1, isn't it? Minus 2k, you have assumed minus 2k is equal to minus 1. So when you are assuming minus 2k is equal to minus 1, okay, you will get k value equal to 0.5. Now it was just an assumption. Now k value, it can be less than 0.5 or greater than 0.5. So here we have got at this condition, what did you get? At this condition, what did you get? K is equal to 0.5. K is equal to 0.5. Now this k can be less than 0.5. It can be less than 0.5 or it can be greater than 0.5. Okay, it can be less than or greater than 0.5. Okay, why it can be less than or greater than 0.5? Why? Because here you have assumed that minus 2k is equal to minus 1. That's why you have got k equal to 0.5. Okay, so this point is what now? This point is our minus 1 plus j0 point when k equal to 0. So when k is equal to 0, when k equal to 0.5, This is our minus 1 plus j0 point. When k is not equal to 0, k is equal to 0.5. Okay, when k is equal to 0.5, this point is our minus 1 plus j0. Now, if suppose k is less than 0.5, okay, so we know on the negative real axis, lesser values lie on the left side and higher values lie on the right side towards the origin. If values are lying towards the origin, they are the higher values. If values are lying on the, as we move towards minus infinity, the magnitude will reduce. Gradually, the magnitude will reduce, isn't it? So, if suppose this is our minus 1 plus j0 point when k equal to 0.5. Now, if suppose k is less than 0.5, then this point will shift to this point. When k is less than 0.5, this point will shift to this point, and that will be our minus 1 plus j0 point, because lower values will lie towards the left side on the negative real axis. Okay, because lower values will lie on the negative real axis. Lower values will lie on the negative real axis. Okay, so I will just check whether I am online or whether you people are able to follow me or not. So, if there is any issue, if you understand the stability analysis, please inform. Okay, I'm trying my best to explain this. Okay, where did it go? Did I discard? Okay, very good. Okay, unnecessarily I discarded. So now, what is this point now? What is this point? This is this point is our minus 1 plus j0 point. It is minus 1. Once again I have to write. I will just go back and screen. I can write here, isn't it? I can't write. Okay, leave it. So this is our minus 1 plus j0 point when k is equal to 0.5. When k equal to 0.5, this is our minus 1 plus j0. Now, if k is less than 0.5, since k is less than 0.5, this minus 1 plus j0 point will shift towards the left side. So, this is our minus 1 plus j0 for k less than 0.5. Okay, for k less than 0.5, this is our minus 1 plus j0 point. Now, if suppose k is greater than 0.5, for higher values, the point should shift towards the right side, towards the origin on real axis. Okay, higher values will lie nearby to the origin, isn't it? On the negative real axis. As you move towards the origin of your negative real axis, the magnitude of the values will increase, isn't it? If yes or no, you just mention whether you are listening to the class or no. How should I know if you won't answer to my questions? Okay, isn't it? As we move towards the origin on the real axis, the magnitude will increase. As you move away from the origin towards minus infinity on the real axis, the magnitude will decrease. So, if suppose k is less than 0.5, then this minus 1 plus j0 point will shift towards left. If k is greater than 0.5, see, if k is greater than 0.5, this minus 1 plus j0 point will shift towards right side. Okay, I hope you are able to understand if you are listening carefully. So here we have assumed minus 2k is equal to minus 1 plus j0. We didn't write j0, but if you remember, in the previous slide I have shown you that minus 2k is equal to minus 1. So if minus 2k is equal to minus 1, okay, then k will be equal to 0.5. Okay, so here we have assumed minus 2k is equal to minus 1. Okay, it's not mentioned anywhere that minus 2k will be equal to minus 1. So k value can be less than 0.5 or it can be greater than 0.5. Okay, so if k value is less than 0.5, then if it is less than 0.5, then this minus 1 plus j0 point, this was our minus 1 plus j0 point, it will shift towards left. Okay, if k value is greater than 0.5, then this minus 1 plus j0 point will shift towards right. Okay, it will shift towards left or it will shift towards right depending on k is less than minus 1, minus 0.5 or k greater than 0.5 depending on the k value. Okay, so I hope you have understood how we have located this point and how we have located this point. Okay. So now we have considered two cases now. One case is what? K less than 0.5. Another case is K greater than 0.5. Now let us consider the first case. Let us consider K is less than 0.5. I will erase all inks. Let us consider only this point, that is K less than 0.5. Okay. So if you observe carefully, this is my minus 1 plus j0 point. Now, if this is my minus 1 plus j0 point, the counter crosses the real axis. Where does this counter cross the real axis? If this is my minus 1 plus j0 point, counter is crossing the real axis. This is my crossing point, isn't it? This is the crossing point of counter on the real axis. Okay, this is the crossing point of the counter on the real axis. So the counter crosses the real axis. Okay, in between what? In between minus 1 plus j0 and the origin, isn't it? When k is less than 0.5, okay, when k is less than 0.5, and if this point is my minus 1 plus j0 point, if this point is my minus 1 plus j0 point, okay, if this point is my minus 1 plus j0 point, then this is the point, minus 2k point is the point where counter crosses the real axis. Okay, so the counter is crossing the real axis between what? Minus 1 plus j0 and the origin. This is our origin. Okay, this is our origin. So it crosses the real axis in between 0 and minus 1, 0. And if you observe the Nyquist counter around this point, okay, around this point, if you observe the Nyquist counter, how it is traveling, okay, how it is traveling around this point, if you observe, what you can see is it travels in clockwise direction 2 times. You just see here around it. This is clockwise, isn't it? This is clockwise. My cursor is moving clockwise. I will take a laser. I will erase all inks. So this is my point, minus 1 plus j0 point. And if you observe around this point, how counter moves around this point? It moves in clockwise direction 2 times. Okay, so if the counter is traveling in clockwise direction, then system is stable or unstable? Can you mention it in the chat box? System is stable or unstable? If counter moves in clockwise direction, system is stable or unstable? Clockwise means system is an unstable system. Okay, system is an unstable system. And there are 2 clockwise encirclements, okay, around the minus 1 plus j0 point. Okay, so there will be no poles on the right half of your closed loop system. Okay, there will be no poles on the right half of your closed loop system. but there will be two poles of open loop system on your S plane. Okay, so no need to mention all those things. Simply what you people do is, in stability analysis, assume k less than 0.5. When k is less than 0.5, you just mention that counter crosses the real axis in between -1 plus j0 and the origin, and it rotates clockwise twice. Hence, system is an unstable system. That's it. Now let us go to the second case, when k is greater than 0.5. When k is greater than 0.5. When k is greater than 0.5, so this is my -1 plus j0 point. This is my -1 plus j0 point. Okay. This is my -1 plus j0 point. Now, if k is greater than 0.5. Now, if you observe, the counter crosses the real axis in between what? -1 plus j0 point and minus infinity. Okay, if this is my -1 plus j0 point, for k greater than 0.5, the counter will cross the real axis in between -1 plus j0 and minus infinity. And if you observe how counter travels here, if you observe how counter travels here, you can see a counter around this -1 is what? It is clockwise. Okay, I'm sorry, this is anti-clockwise. This is anti-clockwise once. Okay, and further, if you see, clockwise. Two clockwise and one anti-clockwise. Both anti-clockwise as well as clockwise. Okay, both anti-clockwise. Nyquist counter travels both anti-clockwise. This is anti-clockwise, isn't it? From here to here, here to here, from here to here. From here, it is clockwise. Both anti-clockwise. The counter encircles -1 plus j0 point, both anti-clockwise and clockwise direction. Okay, therefore net encirclement is 0. We can say both clock and anti-clockwise are there. Therefore, net encirclement is 0. Okay, so therefore system will be a stable system. Closed loop system will be stable. Okay, therefore the closed loop system will be stable. So for what condition system is stable now? Since both are cancelling here, both counters are clockwise and anti-clockwise, system is stable. For what condition system is stable? For k is greater than 0.5. Okay, so in the result we can conclude that. For k greater than 0.5, the system will be stable system. Okay, for k greater than 0.5, system will be stable system. Did you understand the stability analysis? Even if you are unable to understand, you listen after this class, you listen to my class carefully twice or thrice. Okay, definitely you will be able to understand. I tried my best. Okay, I tried my best to explain it to you. I tried my best to explain it to you. So let us go to the next problem. So just if you are you just inform whoever is absent to this, whoever is unable to couldn't attend, just inform them to attend, because this is important concept. Each and every numerical problem that I have been discussing is different. All these numerical problems are not same. So you people, it's best to attend. Okay. So let's go to the next problem. So next problem. So the open loop transfer function of a system is given, that is g of s h of s is equal to 1 plus 4s by s square into 1 plus s into 1 plus 2s. Sorry, there was some disturbance. So our g of s h of s is 1 plus 4s by s square into 1 plus s into 1 plus 2s. Determine the stability of the closed loop system. They have asked us to determine the stability of the closed loop system. And if the closed loop system is not stable, okay, if the closed loop system is not stable, they have asked us to find the number of closed loop poles lying on right half of S plane. So we have to determine the number of poles that are lying on the right half of S plane if the system is not stable. So how many poles are lying on the, we know on the S plane, if poles are lying on the right side of S plane, system is an unstable system. But even if poles are lying on the right half of S plane, and if the number of enclosures on G of S H of S plane in anticlockwise direction is equal to number of poles lying on the right half of S plane, then system is a stable system. Okay. So if the system is an unstable system, how many poles are lying on the right half of S plane, that we have to determine. Also we have to determine the stability condition of closed loop system. So let us consider g of s h of s, that is 1 plus 4s by s square into 1 plus s into 1 plus 2s. 1 plus 4s by s square into 1 plus s into 1 plus 2s. So by looking at this, what we can say? There are two poles lying on the origin. Okay, two poles lying at the origin. That is on the, we can say on the imaginary. I mean, there are two singular points. So we can say that there are two singular points. Write down the question. Write down the question quickly. Okay then, consider g of s h of s. Consider g of s h of s equal to 1 plus 4s by s square into 1 plus s into 1 plus 2s. Okay, so two poles are lying at the origin. So what about the Nyquist contour now? Nyquist contour, actually it should have three sections, C1, C2 and C3. So since there are two poles lying at the origin, there are two singular points overlapping each other. Therefore, what will happen? The Nyquist contour will never encircle the singular points. So it will bypass the singular points. Therefore, another section C4 comes into existence because of the singular point. Okay, because of the singular point, C4 section comes into existence. So total 4 sections, C1, C2, C3 and C4. Total 4 sections are there now. Draw it quickly. Draw the Nyquist contour quickly with free hand. Okay then, let us proceed. Now, let us start with mapping of section C1. I will just increase, I'll explain a bit, means I will increase the speed of my delivering lecture. Why? Because I was very slow for the previous section. So, previous part, okay, for the previous numerical problem. So, now consider C1 section. Omega varies from where? From 0 to plus infinity. Okay. So, consider g of s, h of s, that is 1 plus 4s by s square into 1 plus s into 1 plus 2s. Replace s by j omega. You will get g of j omega, h of j omega into 1 plus 4 j omega by j omega square into 1 plus j omega into 1 plus 2 j omega. So just write it down. Don't write theory, write down only the equations. Okay then. Now determine the magnitude and phase angle for this factors. You have one numerator first order factor, and this is to the power of 2. This is integral factor, isn't? So okay, some to the power of 2 values, their positions were changed. So, okay then. So this is it. So one first order numerator factor, two first order denominator factors, and one integral factor is there. So just write down their magnitudes. So 1 plus 4j omega, you can write it root of 1 plus 4j whole square tan inverse of 4 omega. And j omega square, you can write omega square if you consider in the denominator. If you consider omega square into angle, it is square, therefore 180 degrees. For 1 plus j omega, it is root of 1 plus omega square angle tan inverse of omega. For 1 plus 2 j omega, it is omega root of 1 plus 2 omega square. This is square. I didn't change it. This is it. So these are the magnitudes and angles. Write down all magnitudes on one side and angles on the other side. And see, I have written separately magnitude equation and angles. Write down quickly. So I hope you have written. Let me proceed. If you have not written, mention it in the chat box so that I can show you this slide back. Okay then. Now, so this is our real, this is the magnitude, this is our angle. Now we know that whenever the locus g of j omega crosses the real axis, then imaginary term will become 0, isn't it? Imaginary term will become 0, and the frequency at which the imaginary term becomes 0, that frequency will call it as phase crossover frequency. So what is the angle? Okay, what is the angle at which this imaginary term is becoming 0? So see, this is our polar plot. So what is this axis? Minus, this is what happens. It is minus 180 degree axis, isn't it? It is minus 180 degree axis. Minus 1. I'm trying to write 8. Minus 180 degree axis. So what is the angle when the real terms, imaginary term becomes 0? Whenever polar plot crosses the real axis. Okay. Whenever polar plot crosses the real axis, imaginary term is becoming 0. So what is the angle at that instant? Angle at the axis of that particular instant when it crosses the real axis is minus 180. So angle is what? Angle g of j omega, h of j omega is equal to minus 180. Okay, I hope you have understood. Okay, so the angle is what? Minus 180 degrees. Angle is minus 180 degrees because this is minus 180 axis. Okay, so whenever polar plot crosses minus 180 degree axis, we can say, okay, the imaginary terms are 0. Okay, so that axis minus 180 degree axis. So angle g of j omega, h of j omega is equal to minus 180. So what is our g of j omega, h of j omega? Angle g of j omega, h of j omega, what is it? This is it. This is angle g of j omega, h of j omega. This is our angle. So this whole thing will be equal to minus 180. So this angle will be equal to what? Minus 180. Why it is equal to minus 180? Why? Because the locus of g of j omega, h of j omega, when it crosses the real axis, imaginary terms are becoming 0. Okay, so when it crosses the real axis, so the axis which is crossed here is negative real axis. That is the axis, the angle at that particular axis will be minus 180 degree axis. So therefore minus 180 we must write. So the whole angle will be equal to minus 180. And now simplify this. Okay, simplify the above equation. Rearrange the terms, simplify it. Here already minus 180 is there. Send this minus 180 to the left side. So minus 180, 180 will be, this become plus 180, plus 180, minus 180 will be cancelled. So this is left over. Okay, after some mathematical simplification, I need not explain. There is no need to explain the mathematical simplifications. You can understand. Okay, so now take tan on both sides. So multiply the left side terms of the equation and right side terms of the equation with tan. Tan into tan inverse will cancel each other if you see. So you just rearrange the terms. Look here, simple mathematical simplification. Nothing complicated is there. Just rearrange the terms. Whichever terms are cancelling, you just cancel it and write it down. So I'll give you a minute to write down all these equations. Try to understand and write, copy it down. Okay, now you just simplify it, you will get 4 omega pc. Okay, so why we have written 4 omega pc? Because when the locus g of j omega h of j omega crosses the real axis, the frequency at it crosses the real axis is omega equal to omega pc. So 4 omega pc is equal to what? If you simplify this, you will get this 4 omega pc will be equal to this is what you will get. So 4 omega pc is equal to omega pc plus 2 omega pc by 1 plus 2 omega pc square, you will get. Okay, now you further simplify it, you will get some value for omega pc. Where is my cursor? It is here. So you will get some value for omega pc, that is omega pc equal to 0.354 radians per second. You just check the answer. If answer is not tallying, you just mention it in the chat box. If the answer is correct, then just type the answer in the chat box. Okay, so omega pc we have got 0.354. Now when omega equal to omega pc, what about the magnitude of g of j omega? Okay, this is my, so g of j omega, h of j omega, magnitude is what? You just instead of omega write omega pc, substitute omega pc in the above equation. Okay, so if you substitute, you will get the magnitude of g of j omega, h of j omega as 10.64. So magnitude is what? 10.64. So always remember, for the stability of the system, the counter that is on g of s h of s plane should encircle -1 plus j0 for the system to be stable in anticlockwise direction. So we have got some magnitude for g of j omega, h of j omega, that is 10.64. Okay, so locate that point on the g of s h of s counter. Okay, so here it's only the magnitude. If you locate it on the g of s h of s counter, you must locate it on the left side of your g of s h of s counter, because -1 plus j0 lies on the negative real axis, not on the positive real axis. Okay, so that's why. So here it is purely magnitude. So magnitudes will be always positive. Okay, of course they will be always positive. Now consider. Okay, so you can locate that on the real axis. We will see it later. Now consider g of j omega, h of j omega. This is it. And determine the magnitude and phase angle. We have already determined it, isn't it? In the earlier we have determined. Now substitute omega tends to 0 and omega tends to infinity in the above equation. If you substitute omega tends to 0 in the above equation, you will get g of j omega, h of j omega, magnitude infinity. Okay, magnitude you will get infinity, and magnitude you will get infinity, and angle you will get -180 degrees. And if you substitute omega tends to infinity in your above equation, magnitude you will get 0 and angle is -270. That means -80 means what? This is -80, isn't it? Sorry. This is -80. This is -180 degree axis. Okay, so this cursor won't even listen to me. Where is my cursor? Here. It won't listen to me. This is minus 180 degree axis, and this is minus 270 degree axis. Okay, this is minus 270 degree axis. Okay, this is minus 180, this is minus 270. So, and when it is minus 180 degree, minus 180 degree, okay, when omega is minus 180, magnitude is infinity, and when it is 270, magnitude is 0. Now substitute, now let us plot the graph, or let us map this C1 section. Okay, map this C1 section. So here if you see, we have to locate this 10.64, isn't it? Where is it, my cursor? On the negative real axis. Okay, it will cross the real axis at 10.64. The counter will cross the real axis at, so it will start, you can see here in this plot. So this is, where is my cursor? Yeah, this is minus 180. Okay, this is minus 180. I will take a laser. This is minus 180 degree axis. This is minus 270 degree axis. The plot will start from infinity. Magnitude is infinity, isn't it? From infinity it will start, and it will pass through a point. Some point you just mentioned it as minus 10.64. So magnitude we have got 10.64. We didn't get minus 10.64, but we know that for the stability of the system, okay, so the counter should enclose minus 1 plus j0 in anti-clockwise direction. So even if you get the magnitude positive, you write minus 10 minus, you just add minus to it and mention it on the negative real axis. One of the other reason is why, because your limits are from minus 180 to minus 270. Okay, so minus 180 to 270. So, and this counter has to, we already know, counter has to pass through the point. Okay, so if your plot is traveling from minus 180 to 270, if this point is lying on the right half of your S plane, I mean G of S, H of S plane, so will it pass through this 10.64? It will never pass through the 10.64. So definitely this point has to be located on the negative real axis. 10.64 has to be located on the negative real axis. Locate some point, we don't have any scales, just locate some point 10.64 on the real axis. From minus 180, 270 is what? This is our 270 axis, so you just join it here. Okay, so the magnitude is infinity, therefore from air the plot will start in the air. From minus infinity it will start, so it will be drawn like this. It will just pass through this point and end at minus 270 axis. So I hope you have, okay, this is, I hope you are able to understand. If you want me to repeat, I will repeat it. So one thing you must keep in your mind is that you just check your omega values. Okay, resolving. So you just check your angles, minus 180 to minus 270. So plot is traveling from minus 180 to minus 270, from infinity to 0, magnitude or minus infinity to 0. So if the angle is from infinity to 0, magnitude, angle here, magnitude is infinity to 0, angle is minus 180 to minus 270. So the crossing point, that is 10.64, it cannot be positive, it has to be negative. The crossing point on the negative real axis should be negative, not positive. Okay, so I hope you are able to follow. So I am going to the next slide. Let us go to C2 section. So cursor. So this is a mapping of C2 section. So while considering mapping of C2 section, we know the radius is what? Radius r tends to infinity. So s is equal to limit r tends to infinity r e power j theta, where theta varies from where? From plus pi by 2 to minus pi by 2, and where s tends to r e power j theta, where r tends to infinity. So you substitute r tends to infinity in this. If you substitute r tends to infinity, s will be tend to infinity e power j theta, means s value is very very high. So when s value is very very high, 1 plus st can be written as st. Why? Because 1 is very very small. 1 is very very small when compared to st. So 1 plus st is st. So if you have any first order numerator or denominator factors in the given equation, just replace them. So what is our equation? G of s h of s is equal to 1 plus 4s by s square into 1 plus s into 1 plus 2s. So we have three terms here. So 1 plus 4s will become 4s, 1 plus s will become s, 1 plus 2s will become 2s. Okay, based on the discussion just now what we have done. Okay, so this is what you will get. Cursor, where is my cursor? This is it. This is it. This cursor is very small. I am unable to see it. So this is it. So 4s by s square by s into 2s you will get. So s is cancelled, 4 by 2. So 2 by s cube you will get. So g of s h of s is equal to 2 by s cube at what? At s is equal to limit r tends to infinity r e power j theta. Substitute s value in the 2 by s cube equation. So if you substitute 2, you will get 2 by limit r tends to infinity into r e power j theta whole cube you will get. So substitute r as instead of r, substitute infinity. If you substitute instead of r infinity, what do you get? 2 by infinity is 0. E power j theta cube is there. Send it to the numerator, e power minus j 3 theta you will get. At the end of the class, I will forward the Google form to fill for attendance. Okay then. So here you have got 0 e power minus, where is my cursor? Yeah, 0 0 e power minus j 3 theta you have got. So substitute theta equal to plus pi by 2 and theta equal to minus pi by 2 in the above equation. You will get g of s h of s equal to 0 e power minus 3 pi by 2 and g of s h of s is equal to 0 e power plus 3 pi by 2. Okay, so it is varying from minus 270 to plus 270, and radius is what? Radius is 0. Okay, radius is 0. So simple. Okay, so radius is 0 and the contour will travel from minus 270 to plus 270. Minus 270 to plus 270. Okay, so this is it. This is our contour on C2 plane. So this is our C2 plane. This is our contour. So you can see it is in clockwise direction when theta varies from where? From plus pi by 2 to minus pi by 2. So here it is. This is our, what is it? This is our plus 270. This is our minus, sorry, okay, minus, let us consider it as minus, minus 2, okay. This is minus 270. Okay, this is minus 270. So if it is if theta varies from minus 270 to minus negative to positive, then counter should be in anti-clockwise direction. So you can see, so from here to here, this is our plot. Okay. So once again, I will try to draw. My cursor is not listening to me, but I travel my best to see. I don't know why this line is coming into existence. Why this line comes. So better I will take the laser. So this is it. From here, plot will start. It will travel like this, and it will end here. Okay. So this is our minus 270 degree axis, minus 270. This is plus 270 axis. So plot will start from minus 270 in anti-clockwise direction. It will travel and end at plus 270 axis. So plot it quickly. Okay, then let us go to C3 section mapping. So it is the easiest mapping section. Why? Because C3 is just the image, mirror image of C1. That's it. Okay. So C3 omega varies from minus infinity to 0. Okay. So the locus of this G of j omega, H of j omega, their locus will also vary from omega equal to minus infinity to 0. So it is the inverse polar plot, okay, of your C1 section with respect to what? With respect to the real axis. So what our plot that we have got? C1 plot. Just look at the C1 plot. This is our C1 plot. Okay. So just opposite to this, we will plot C3. So this is our C3. Just opposite to your C1 plot, this is our C3 plot. Draw it quickly. So let us go to the next C4 section, mapping of section C4. So mapping of section C4. Okay. So when you are mapping section C4, S will be equal to limit R tends to 0. So I didn't remove this bracket. So bracket will not be there here. R e power j theta, where theta varies from minus pi by 2 to plus pi by 2, where S tends to R e power j theta and R tends to 0. So r is tending to 0 means s will tend to 0 e power j theta. S is tending to 0 e power j theta means s is very very small. Therefore, 1 plus st will be approximately equal to 1. So consider g of s h of s. It has 1 plus 4s s square into 1 plus s into 1 plus 2s. So 1 plus 4s will become 1 and 1 plus s will become 1, 1 plus 2s will become 1. So 1 divided by s square into 1 into 1, we will get 1 by s square at s is equal to limit r tends to 0 r e power j theta. So this bracket is not there. I will remove the bracket now itself. You people just note it down. This is it. You people, if you are able to follow or not, respond in between so that I will be knowing that people are listening to the class. Okay, now let us substitute this s in the above equation, g of s h of s equation. So if you substitute s in the g of s h of s equation, so what do you get? G of s h of s at s is equal to limit r tends to 0 r e power j theta is equal to 1 by s square. Substitute s value in the above equation. You will get 1 by limit r tends to 0 r e power j theta whole square. So you just substitute r equal to 0. So if it is r equal to 0, 1 by 0 you will get infinity. Send e power j theta square to the numerator. You will get e power minus j 2 theta. Now substitute theta equal to minus pi by 2 and theta equal to plus pi by 2. Okay, so if you substitute theta equal to minus pi by 2 and theta equal to plus pi by 2, then you will get magnitude infinity and e power j pi. And for theta equal to plus pi by 2, magnitude infinity e power minus pi, j pi. Okay, so theta is varying for our for g of s, h of s. On the counter for C4 section, its magnitude will vary from plus infinity, magnitude is infinity, and theta will vary from plus pi to minus pi. Okay, so theta will vary from plus pi to minus pi. Let us see how to plot this contour. For C4 section, we are about to finish this numerical problem. So let us see the contour. So it is varying from plus pi to minus pi. So what is plus pi? Plus pi means, where is the cursor? Yeah. So this is our minus 180, isn't it? This is minus 180 and okay, upper one is plus 180, lower one is minus 180. Okay, from plus to minus, isn't it? This is plus to minus. I have already told you, if you are traveling from positive to negative, then you should move in clockwise. If you are traveling from negative to positive, the angle, if theta varies from positive to negative, you should move in clockwise. If theta varies from negative to positive, you should move in anti-clockwise. So theta is varying from positive to negative. So plus 182 in clockwise, plus 182 minus 180. Okay, plus 180 to minus 180, you will get a complete circle. So this is the contour for C4. This is the contour for C4. Now join all the sections. If you join all the sections, C1, this is C2, C3 and C4. If you join all the sections, you can see C1. So I will take a laser, my cursor won't obey me. So this is our C1 section. C2, C2 section. C3, C3 section. Then this is C4 section. So just observe carefully. C1, C2, C3, C4. So if you compare with the previous problem, there is no K value here. A complete, you can see on the negative real axis, a numerical value minus 10.64 is there. So if this is minus 10.64, where is my cursor? This is laser, okay. I'm going to take pen. So this is my minus 10.64. So definitely there must be a point here. Some point must be there. Some point here which is minus 1 plus. This is what happens. So there must be a some point here which is minus 1 plus j 0. Okay, there must be some point here towards the origin on the negative real axis whose value is minus 1 plus j 0. Okay, so if you observe here around minus 1 plus j 0, the plot is or the contour is enclosing this minus 1 plus j 0. Okay, so you just observe, this is clockwise encirclement, isn't it? Again, one more clockwise encirclement. Two clockwise encirclements are there. Okay, so this minus 1 plus j 0 is encircled twice in clockwise direction. Okay, so there are two times it has been encircled clockwise. Okay, so since it has been encircled two times clockwise, there will be two poles lying on the right half of S-plane for closed loop system, but there will not be any pole on the right half of S-plane of open loop system. Okay, so if I say both, you may get confused. So just remember that if minus 1 plus j 0 is encircled clockwise twice, there will be two poles lying on the right half of S-plane. Okay, so is the system stable now? Clockwise, two encirclements of minus 1 plus j 0 in clockwise means system, is it stable or unstable? It is an unstable system. It's not stable. Okay, so minus 1 has been encircled clockwise twice. So two poles will be lying on the right half of S-plane for the closed loop system. Okay, so system is not an stable system. System is an unstable system. Okay.